Hi everybody. In this lecture we're going to talk about VEX and especially what we can do with the language. Now VEX is a language which is both represented as a textual format but also as a visual format. Um, Therefore it's quite interesting for artists because it gives you quite the same interface as that you're used to work with over here. Just one difference that we're going to see uh, right away is that over here the node structure goes from top down, and if we're working in VEX it goes from left to right. Um, Now with VEX we can do several things. We can use it in each one of the systems, so you can use it in SOPs for creating geometry or let's say modifying geometry. You can use it also in the compositing, you can use it in the shader part, in particles, basically in everything that we find over here. So if I press W, so in all the paradigms you can use VEX as a language. Now the powerful thing about it is that you also can interchange data from one to another and use it to adjust certain things. Important to know with VEX as well, especially within SOPs, is that you can use it to modify data, but you can't use it to create new things. For example, what you can't do is just create out of a VEX node something which generates or creates a cube. You can create, however, things that adjust all the data or the information which is over here, or you can make sure that you delete certain things and so on. But you can't build up things from nothing. Okay, so let's get onto it. Let's start by creating a FOP SOP. So I believe it's over here. You find it underneath utility. Well, it's falling off the screen, but you will find right down there that you find a FOP SOP node. And so if you click it, you see you have this node with multiple inputs. Right now we're only interested in the first input, so let's connect this one. And you see it's available. Since we didn't do anything with it, it's just passing through the data as it came in, so nothing has changed on this cube. Now if we double click this node, we get in this node and we see like we're somewhere else in a different spot. So if you can see it, we can open it over here. We see the FOPSOP, we went into it, and we see right now the global and the output. The global is presenting all the default available data. For example, the point position, velocity of a point. It's not necessarily that it is all filled in, but those are like the basic attributes that we have. Point age, this is all things which is important for particle systems, but we have also point color attribute, point normal, the total number of points so that you can do certain things to a number. Over here we have each point number, so it's a little bit the same like point identity, except this one is for particles. Point identity is unique even if you kill a particle. The current time in seconds, current time in frames, so all kinds of data that you can use by default. Later on we will see how you can also add your own attributes and that you can read out attributes just like that. And on this side we have the output attributes that you can modify. So we have the point position, a few things which are just important for us, point color, point normal, etc. And so basically what you can do is we can just start cross-referencing or just adding values to certain things. For example, we see the point normal over here. What I can do is I can connect these data types to each other. For example, we have the point position, which is a vector, and you can recognize vector by this greenish kind of color. And if we connect it with the same attributes or the same type, we connect it over here, we see that we have taken like the point position for generating the normals. So basically this is just using the point position from the center, and then using that as a vector for generating the normal. So if we go up, and I would add a transform node right over here to adjust it, then you will see that those normals are updating. Now those are things that you could do also with a point SOP, using an expression or using the variables. But something which is important to know is if you can do things like that within VEX, most of the time they are usually much faster. So let's try and do something else. What I can connect as well is, for example, using the point position and connect it to the point color attribute. And so this is now being used to adjust the colors. And as you can see, we have like this little bit of green over here. It's because this box is like 0.5 high, and because this is the Y value, we see it's now connected to the green axis. The X value is connected to the red color, and the Z axis is connected to the blue color. It's just like a default mapping that we have right over here. But you can do this with all kinds of things. As we can see, we have like this change of properties, or how we change things, and like that we can add color. For example, if we add now a normal by using this facet SOP, and let's add normals over here, we see something like this. Again, we can do the same thing by going in and connecting the normals to let's say right here the point color attribute, and now we see the normal direction. So everything which is pointing into a certain direction. This is a little bit like a normal map. It's quite comparable to that. And as you can see, it is also quite easy, and something I will show you later on, how to create or to generate a normal map out of a Houdini rendering. It's extremely easy to do over here. Alright, so these are just basic connections. Now let's go a little bit further, because there are of course many more nodes and things that you can use. So if you press tab, you see we have over here like this whole list of tools that we can use. For example, in the beginning we have combine, all kinds of ways to combine data. You will find many things back in other parts, such as over here in the mathematics. These ones with the combine, those are things that you use very often. You have the convert, also quite important. Things I will show you later on, especially if you want to adjust only certain values or certain parts of the data, then it's sometimes important that you can split up or open up parts of a vector, or recombine them again with three geometric functions, sinus, cosinus, all those things. Digital assets, this is more for the shape, so this is not really that important right now. This is also for shading, generic, color correction, U shift. These speak for themselves. Geometry, this is a part of data which is kind of specific to the to which the VEX control is being placed in. So right now we're into geo, so to speak, the surface operators, and if you generate a VOPSOP right over here, then you have the ability to have like a lot of access to all this geometry data. If you would go, for example, to a different kind of VEX elements, for example the shading, creating shaders, you won't find as many of that information over there, but you would find many other things. For example, in the shading you would find many more data elements that you can use. globals, as you can see, global variables, you can add like extra global variables, but this is not really necessary for what we're going to use. We're going to do that somewhat different. Output variables, all kinds of volume subs. Patterns, this is also very important because over here we can add all kinds of noises or other kinds of patterns, things that we can use in various ways. A quaternion, this is specific for object rotations. It's kind of difficult to use. I hardly use it myself, but if you want, you can specialize to do things a little bit deeper into that. Something which is more likely to be used with particles than just in geometry. Shading UV, so we have like the rest position for the UVs, etc. Then for this we have utilities, and utilities are like those basic functions that you can find for a language. So an AND or not for loop, switches, all those kinds of things you can find over here. You will find also the interface tools such as parameter over here or ramp parameter, things I will show you as well later on. So these are things in which you can generate your interface a little bit for this FOB-SOB. And then right here, this is also a very important one, vector, all kinds of vector tools, how to create a cross product, a dot product, measure length between 2 points, minimum maximum vector component, all those kind of things. Volumes, this is not something we're going to see right away, although it's very interesting, but this is more specialized on working with volumes, of course. And then collect is something new, I don't know it myself yet, something I might address in a future lesson. Alright, so let's start doing a few things. For example, let's take over here the point position. What we can do is we can use, for example, a basic function, and let's add one. What I'm going to do is I'm going to normalize the point positions. Right now the point positions, they have like a specific hard position, and what I'm going to do over here is I'm going to normalize its value. So if we're going to go over here to vector, we will find over here normalize. So as you can see, we have again a vector input and a vector output connected over here, and if we go back with this normalized version, which is now an adjusted version of the point position, and we connect it to the output point position, we're gonna see that suddenly we create some kind of a sphere out of this. And that's why that's because normalizing is making all those points or all those vectors unit length. So if they're too close, they're going to be pushed out. If they're too far away, they're going to be pulled back, and that's why you're gonna get something which looks like a sphere. Might be useful in some cases. And you can continue doing things like this. For example, we can create a blend regions or a blend node. This is not exactly what I had in mind. The blend regions, I think it is the mix I need to use over here. And in this mix we can use like two values and we can get an output. But as you can see right over here, we see a dark color. Now this dark color is in fact a floating point value. Now, like I said, each one of these colors, they represent their own type. Like this bright green, it represents a vector tree. The darker green represents a float. The blue over here represents an integer value. Now if you would have, for example, a vector 4, and let me show you this right now, a vector, let's say a vector 4 to vector, it's a conversion tool. You can see over here that a vector 4 is represented by even a brighter green, but the arrow inside is turned black. So they all have their own color code. We will see more of them later. So what I'm going to do right now is I'm going to make sure that I can blend between this spherical deformation and between its normal points. Now, as I said, this is like a floating point value. And what Houdini can do in lots of cases, not in all cases, is it can automatically convert from one type to another. So if we take this one over here and I connect it, you will see that it suddenly turns into like a vector value instead of a floating point value. Now it's asking for the next input, also again a vector value. So here I'm going to take the original points and I'm going to connect it again right over here as an end result. And now we see we have some kind of a blend between both of those values. So we have like something which is almost a sphere and almost a cube. But if we go outside, this is now something which I want to control, but if we go outside of the node, we see that we don't have any interface for that. I can't control it right over here. And this is something I want to change. So if I go over here, we see we have this value open. And to make that accessible, we can add right over here within the utility, we can create, for example, a parameter by adding a parameter node. And as you can see, it's just creating for us a parameter with a name. Now these are names that I've added myself. I made this like a permanent default because it's easy with this expression that whatever name I type in over here, for example, multiply, it's going to change the name and the label automatically to exactly that same name. So it's going to change it to the operator name, and that makes it quite easy for me so that I don't have to type each time again something new over here. Now you see that we have this parameter over here and I can just in real time start playing around with these values. Of course you can go the other way around, you can go negative or you can go much more positive. And so like that you can create your own deformer tools or tools that do all kinds of operators. Okay, let's go inside again. Now there are different ways how to do this. What I've shown you now is a way how to add something like that manually. But what you can do over here is you can also right click on this one and you can create the input parameters. So what it's going to do in that case, if you click the node right button over here and create input parameters, it's going to create all the input parameters for all of the inputs which are not being used yet. So in this case just one was left and we have one value over here, and if we go out again we see interpolation bias. This is just taking over the name directly what was over here, and we can see like that we again have like the control. It's also using the default value that was inside as its own default value to adjust it as a parameter. Now you can see it over here as being like this small knob. This is a new feature that has been added since Houdini 11. And the reason for that was several of those nodes, they had like lots and lots of those input parameters, and this could really clutter your view. You could imagine, for example, if I do this with all of them, then I have like all these parameter nodes, and that would make it very difficult to read. Like that, this is some kind of a simplification. But imagine that you want to change something like that, you can still select this and you can make it visible. For example, you can expose the inputs and then we have exactly the same thing. Or you can go the other way around and you can hide it over here, I believe. Let's see, normally seen hide. So hide outputs, that's something else, it's not what I had in mind. Expose outputs, it's somewhere probably over here. Collapse outputs, no, it's not what I had in mind. Perhaps I have to do it over here. Hide inputs. We get something like this. Or we can select it right over here. Oh, I selected the node, it was not the idea. If we right click over here, no, I have to do a middle click. If you middle click over here, you can hide the input nodes and you get again this. So, but as you can see, it's not something that I often use. So that was one way to create one. And so by again selecting this over here and create input constants or input parameters. A constant is something different. A constant is just a value that you can add but that you can't access from outside. So again, middle mouse button and for example promote parameter. Again, it does the same thing. So those are three ways how you can create like these input parameters. And let's go back up. And so this concludes the very first part on how to create VOPSOPs. So the thing that we've seen is we've seen a little bit what the language looks like. We've seen also how we can connect different data types. I've shown you a little bit what's inside, what kind of operators that you can do, what you can expect, and how you can cross-reference and use all these values to create something new out of that. This concludes the first lesson.